Hey guys, this is Mr. Sal. Thanks for watching. This is 4.2 section on multiplication of polynomials. Don't forget to like, comment, and subscribe. Well, when we're looking at multiplying a polynomial by a monomial, or just one term, it's not too bad. It's once we start looking at multiplying polynomials by other polynomials. We have to be really good at distribution for this, okay? And in a way factoring as well, which we'll get into. So if we see something like this, which we may, we can separate all those terms because it's all multiplication. For example, between the 7 and the x, it's multiplication, and between the 3 and the x squared, it's multiplication. And then between the parentheses, right there is multiplication as well. So that's what this next row is, just showing that it doesn't matter, we don't need to show the parentheses. And then this next row is the commutative property of multiplication, just to move stuff closer to each other that's like each other. So 7 times 3 is 21, and then x times x squared would be x cubed. Now it's not imperative that you show all these steps, but you should show some work, right? Now once we start seeing addition and subtraction in this one of the sets of parentheses, then we got to keep track of stuff, of more stuff there. All right, so here we go, right? I mean, the same concept that we just saw. I'm going to show all the steps on this. So I'm going to change 6x to 6 times x, and then we're going to multiply this by the other parentheses, 2 times x squared. And then I'm going to use the commutative property to change stuff around to move the numbers closer to each other and also the x's. So now I got 6 times 2, which is 12. And then I've got, that'd be really x to the power of 1 plus 2, just to look back at some exponent rules, which is 12 times x cubed. And that's our answer right there. I don't know if they're easier, but they just go faster. When multiplying monomials by binomials, trinomials, polynomials, then we're looking at distribution, which we will see in this next example anyways. All right, so I'll show all the steps. Again, it's not necessary that you would have to show all of them, but you should show some, okay, because that was one of the problems we saw in this last test so far in the grading, is not everyone's showing all of their work, which is causing some points to be lost, okay. Don't be over anxious. If you showed your work, then you're good. Okay, but if you didn't, sorry, it was on the front page, right? All right, so by distribution on this, I need to distribute the 4x cubed to all 3 of the terms on the inside there. So I've got my 4x cubed, and to start out, it's being multiplied by the 2x squared. And then we've got the 4x cubed being multiplied by, that's a negative times negative 1x. And then we got another 4x cubed. Now it's being multiplied by negative 5. So I put the multiplication there in between those just so we can see it's not minus. And the 4x cubed was always positive. All right, so combining these, well, I would use the commutative property here. So I've got 4 times 2 times x cubed times x squared, which would be 8x to the 5th. And then this next one, I'd have 4 times negative 1 times x cubed times x, which is negative 4x to the 4th. And then our last one, we've got 4 times negative 5 times x cubed, which is negative 20x cubed. And this bottom row here would be our final answer for that. All right, I don't know. Sometimes this doesn't make complete sense. All right, but when we combine 5x and 2x, it's kind of like we factored out the x, which is what the second line here is telling us. and then we just combine the 5 and 2, which would give us 7x. Okay. Now, generally we just say if I have 5 x's and then 2 more x's, I would have 7 x's, which kind of, right, we would show that with the v thingy, right? There's no formal name for that. But it works the same way for if x were some kind of polynomial, right? If I had 4x plus 1 and 3x plus 1s, then I would really just have 7x plus 1s right there, right? Right here. And then from there, it would be pretty easy to distribute that 7. 7 times x is 7x, 7 times 1 is 7. And that would be a fully simplified answer right there. It'll work the same way when maybe instead of 4 we have 4x. It's just we wouldn't be able to combine the 4x with the 3 like we did in this step right here. I think we see that. So when we see a multiplication of two polynomials like this, it's like we're saying I'm going to take 4x times that parentheses, and then I'm going to take 3 times that set of parentheses as well. So the 4x times x plus 1 gave us this multiplication right there, and then 3 times the set of parentheses gave us that one. And from there it's all distribution and then combining like terms, right? So we can see on this third line 4x times x right here, 4x times 1 here, 3 times x here, and then 3 times 1 there. And then it's all simplification after that. Some people want you to memorize that FOIL garbage. You can if you want, first, outer, inner, last. But if we understand exactly what's happening on this, like we see on this, then it's no need to memorize that kind of stuff, okay? All right, multiply and simplify. So I'm going to do this the same way we saw that last example. So I've got x times that 2x plus 3, and then this is a positive 5 times the same polynomial, 2x plus 3. All right, so I'm just taking each term and multiplying it by the other set of parentheses. Now I can distribute my x, so that'd be 2, I'm going to skip a step, 2x squared, and then x times 3 would be 3x's. And then I'm going to distribute the 5. 5 sets of 2x would give me positive 10x's. And then 5 sets of 3, positive 15. And that feels pretty good. I mean, this is pretty new and we nailed it, right? The problem is that there is one more step we should take, and that's to combine our x's right here, right? If I had 3x's and 10x's, I would have 13x's. The rest of it stays the same. So this right here actually would be our final answer, fully simplified. All right, so the same concept, right? I'm going to take my 3x here, and I'm going to multiply it by this other parentheses. So I've got 3x times that set of parentheses, 4x minus 2. Then I've got this negative 3, which I'm going to be multiplying by the same parentheses. Well, I should put that in black. Okay, so see how the red and the purple came from that first binomial? And I have to multiply each of the terms by that other binomial, 4x minus 2. Which allows me now, again, to distribute into the parentheses. So I'll show more work on this. So now I've got 3x times 4x, and then I've got 3x times negative 2. And now I'm going to distribute the negative 3. So well, I'm just going to write negative 3 times 4x. And then I've got negative 3 times negative 2. So combining these, 3x times 4x would be 12x squared. Plus 3x times negative 2 would be negative 6x. And then we got negative 3 times 4x, which would be negative 12x. And then negative 3 times negative 2 is positive 6. Now once again, we do have these two middle terms to combine, because they're like terms. X's, if I took negative 6x's and combine it with negative 12x's, I'd have negative 18x's. The rest of it stays. I'll do this one a little faster, maybe, if I can write it faster, I guess. But the concept is still the same. I'm going to take this y and multiply it by this other parenthesis. And then I'm going to take my negative 2 here and multiply it by the same parentheses. And then I'll distribute these 2 into both sets of parentheses. So I got 4y squared minus 4y minus 8y plus 8. Well, then we'd combine these two sets of y's on the middle. Negative 4y minus 8y is negative 12y. And that would do it. Alright, now we got three, factors to multiply on this. And it doesn't matter which order you do them in, okay? Just as long as you don't double up on stuff. So what I would recommend doing is distributing the 5t into this first set of parentheses. So I've got 5t times 2t plus 5t times 7. And then this will still be in a set of parentheses, which we would need to multiply by t minus 4 here. So just simplifying this, I'd have 10t squared, and then this would give us 35t's here. That's positive 35t. Now we'll multiply this by t minus 4, not that it would matter. So what I mean by that is, if you took the 2t plus 7 and multiplied it by t minus 4 first, it would be okay. Again, it's just a matter of preference. So now I'm going to take the 10t squared and multiply it by the set of parentheses. And then I'm going to take the 35t and multiply it by the parentheses as well. Alright, now we are ready to distribute these into the parentheses. So 10t squared times t would just be 10t cubed. And then 10t squared times negative 4 would be negative 40t. 35t times t would be positive 35t squared.
What would be t, negative 40t?
Got that up there. Then 35 times the negative 4. Alright, then of all these, we have the t's that we can combine here in the middle, which would leave us with negative 5t squareds. So this problem is one of the reasons why I don't like FOIL, because if we have three terms, then what do? I mean, I have no idea what they would call it. But if we just do the same, you keep using the same method that we have been, I'm going to take r and multiply it by that parenthesis. And then I'm going to multiply negative 1 by the same set of parentheses. Now when I distribute these, it should work out pretty good. R times r squared is r cubed. R times r is r squared. And then r times 1 is r. And then negative 1 times r squared is negative r squared. Negative 1 times r is negative r. And negative 1 times 1 is negative 1. So we're looking at the different terms to combine. Here I've got r squared minus r squared, which means they really just cancel out. As well as the r and the negative r right there. Those are going to cancel out as well. So what am I left with? I got the r cubed, which had nothing else to combine with, and then the negative 1 as well. These just stay, and that'll do it right there. You'll see this is a very unique case when multiplying trinomials. Looks like on the homework we're going to see some applications of this stuff. Usually we do use rectangles, but in the past when I've showed it, it's only confused students. So I'm not showing it to you guys. However, we're going to kind of see it in this case. Find a completely simplified expression for the area of the blue shaded rectangle. Okay. Well, the area is length times width, so the area of this blue rectangle will be the length. I'm going to say that's 4x plus 4 times the width, which I'll say is 4x minus 4. Well, this is nothing new, right? We've just seen this. And so I'm going to take my 4x and multiply it by the parentheses. And I'll take my 4 and multiply it by the parentheses. Now we'll distribute into both sets of parentheses. And the x's here in the middle, these are going to cancel out. So we're just left with 16x squared minus 16. And they didn't give us any labels for these, meters, feet, so we'll just leave it like that. This is a good opportunity to show you guys as well. So what they would do on this is they would separate this, and they would say this length is 4x, and this length is 4. And then they would separate this one, and say this is 4x, and this is negative 4. And then you find the area of each section of the rectangle. So this is 4 times 4x. This is 4x times 4x. And then this one would be negative 4 times 4x. And then this one would be negative 4 times 4. Now, yeah, we do get the two sections that cancel out, right? These two. But it would give us the same answer eventually anyways. This one just wants us to find the area of the blue region, not the middle part. So what we're going to do is we're actually going to end up treating this like it's just a full rectangle and ignore that part that's in the middle that's been cut out, right? And once I find the area now of this red part, then I can take it and then subtract that white part out of it, okay? But we do need to find the area of this full rectangle first, which would be length, so I'm going to say that's x plus 5 times width, x plus 9. So now I've got x times a set of parentheses, and I've got 5 times the same set of parentheses, and then we'll distribute into those parentheses. So the area of the whole thing, I mean without the cutout part, would be x squared plus 14x plus 45. Now let's look at that actual cutout portion, okay? So that means we're going to have to subtract from our original area whatever that white area is. And that white area is length, x plus 7, times width, x plus 2. And we'll work this out. So we found the area of that middle white rectangle. And we are going to subtract that from the x squared plus 14x plus 45. I'm going to do that just like we did in 4.1, right? I'll write it out and then subtract. But we're in this, we're going to subtract each of these like terms, okay? So x squared minus x squared, those cancel out. 14x minus 9x would be 5x. And 45 minus 14 would be a positive 31, which would be the area of the blue shaded region.